So let me start first with non-lethal weapons. This is just an interesting program, I think, where you can see this is an untethered taser, if you will, that the program office, in this particular case, the non-lethal weapons program office, came to us and said, okay, we'd like you to do a little bit of an analysis on this. We have this round, we'd like to be able to fire this about 100 meters away, and we'd like to know how accurate can we be, and what are the conditions in which we need to be concerned with respect to firing this round. It's a 40 millimeter round, it's launched from a grenade launcher, and so the group in this particular case looked at aim, angle, scattering, and muzzle velocity, and how that affected the accuracy. Also, there's one final thing I'll mention here. In getting a target and aiming it, they also were looking for new ideas, and there was some commercial technology that appeared kind of interesting, and so I'll show that in a second. So first of all, how might you do something like this? Well, again, it comes down to the physics of motion here, right? You need to think about if you aim this thing, how far are you going to be off depending on the angle at which you control this particular device, and in this case it's a grenade launcher. So you can go through the motions and you can come up with, at 100 meters, you can be off by 1/4 to 1/2 a meter. 1/4 to 1/2 a meter, if you want to hit someone in this range, is pretty bad, right? You have to be worried about that because you'll probably miss your target. So that's what they wanted to know. They, again, think about what's physically possible here and whether or not are we bounding the problem right for them, all right? And the other thing is that, can you make it any better? Well, you can make things go faster. You can get a little gain in accuracy by making things go faster, but then you have to think, is it still a non-lethal weapon, right? If I hit somebody, let's say at 100 meters and it works, and by the way, that projectile had little needles that came out of the front of it that would go through, make contact, and then the bottom half would drop off. If it touched somewhere else on your body, that's what gave you the tasing effect. And it had its power supply, of course, contained in it. So in this particular case, you have to ask yourself, well, okay, if I do that, what happens if I hit somebody at 30 meters? Do I kill them, right? So you have to be, it's no longer a non-lethal weapon, and therefore could be a problem, right? Could be an issue that we need to think about. So increasing, it's pretty obvious, increasing the muzzle velocity improves accuracy, but then you need to run these trade-offs, and you have to, again, bound the problem. Okay, I mentioned commercial technology. This is interesting, where the team thought of, well, what are some things in which we could look at that would actually help us aim better, for example. In this particular case, you may recognize up there the Kinect system, which is part of an Xbox system, if you will. So we actually got permission to buy an Xbox. We actually bought, well, not an Xbox, we bought the Kinect system. We actually bought 2 of them. And in this case, the person in my division did a great job writing a little program and connecting to the particular Kinect system a program that controlled this little Nerf shooter here, if you will. It's a Nerf gun. And I actually took Dr. Chu in one of our little lab areas, if you want to call it that, and had him stand there. We were standing there in the dark because this actually works in the near IR. And it would size you up, and on the computer screen you could see it would measure you and actually fire the Nerf gun and hit him right in the chest. So, so anyway, but I think this is a great example of where we might be able to bring value to a sponsor, all right? The Kinect system in this case was about $100 to $150. That's a very inexpensive piece of equipment by any DoD standard, right? So if you think about it, if you could use something like this and use it effectively, and of course there's going to be an issue with respect to how far away you have to be and so on, if it's useful, it's way to go. So this is the kind of thing that I think is good, and this is the kind of sort of out-of-the-box thinking that we do here at IDA, which I think brings a lot of value to our sponsors.